Hello grade 12s. Today I'm looking at the trial paper of 2016, and this is question 2, the development and curve of interpenetration. So what have they given you here? A square pipe with a circular branch pipe. They've got the auxiliary views, which is going to help us get our pizza slices. The axes aren't on the same point. What they want you to do is complete the front view showing the curve of interpenetration, develop the branch, so in other words the circle, show all construction. So with the top view here, we're obviously going to have the ellipse come up here, so that's why the top view there's quite a big mark allocation, the 12 points of the ellipse. So I think let's get going with the ellipse. So we're going to divide our circle up into the 12 slices and do the same with the points in the front view. So with these drawings, you've noticed that I like to label the points so we can follow each corresponding point when we're trying to find points in the new view. The problem with this drawing here is that our circle has been rotated to become an auxiliary view. But this is my highest point of the circle, and if I follow it across, I would label that as my highest point and then go clockwise around the shape. No real reason for going clockwise. You can go anti-clockwise. So, oopsie, left out 7. Now, what we need to understand is that that has been rotated at 30 degrees. So if we had to bring it around to another circle here, so as it's rotated 30 degrees, if we turn this down by 30 degrees, what we would find is point 0 and 12 would be the highest point there. Okay, 1, 2, 3, 4, 5, 6 at the bottom, 7, 8, 9, 10, 11. So our watch face would have turned by 30 degrees. Okay, there was normally our highest point, it's turned 30 degrees. Now, when we get this into the top view, we need to rotate from our vertical 90 degrees. Okay, the angle between the front view and the top view is 90 degrees. So if we're imagining there was 0, okay, once this had been rotated, that was where 0 would have been in the front view. We've got to turn it 90 degrees, meaning there is 0, and we would label our shape this way. Okay, so quite important that the labeling 0 is the highest point, but if we had to bring it down to parallel to the base of the shape, we'd have to turn it by 30 degrees. Then to go from the front view to the top view, we rotate it 90 degrees. Okay, let's project our points for our pizza slice into the top view and into the front view. So I've projected my points. I know 0 and 12 at that point, and coming down, the same I've done with my top view. I'm going to just label my corners now here in the front view, because then we're going to project them down to get our ellipse in the top view. So let's project our points down now. So we need the theory of 2 points, one vertical line, one horizontal line. So here is line 0. So if I project that down, that is going to give me point 0 and 12. Next I'm going to points 1 and 11. There's 11 and there's 1. Follow the same process. So line them up. Here's 2 and 10. Project them 2. There's 10. And there's my horizontal for 2. We follow the same process. A lot of these drawings always use the same process. Now it starts coming back. So there's 8, 4, 5 and 7, and the last point 6. And we can now join those up. If you've got a flexi curve or French curves, those will be the best way to join that up. There we have the completed ellipse and completed the top view. So now we need to find the points that we need to take up to find our curve of interpenetration in the front view. So you'll notice that I projected my pizza slices to touch my main pipe when I projected them across to get the ellipse. We're going to use those points now and project them up. What I'm going to look for though is the part that I'm going to see. So here is my turning point. Now that turning point we're going to calculate a little bit later, but at that point that is all we can see. So the points we can only see will be 1 and 5, 2 and 4 and 3. So those are the points that I'm going to start with, and then calculate the turning point, do that little aspect that I can see, then work on completing the hidden detail side, which is behind the turning point. I'm going to start at the bottom of my shape. So the first point I want to find is point 3. So where point 3 hits, I need to project it up to where 3 comes down from my auxiliary view. Okay, so there is my point 3. My next point is point 2 and 4. So once again, here is point 2, here is point 4, and I need to project these points up to cut them there. So there is point 2, there is point 4. The last pizza slice we'll see on this side of the shape is 5 and 1. So I'm going to project that. There's where it hits 5, there's where it hits 1. Now we need to find the turning point. So what we're going to do is, much like we've done with the other ones, project our vertical line. Sorry, that I've done already. That's the wrong point. Here's the edge point there. So we've projected our vertical turning point line here. Now we need to find it in our auxiliary view. Where it touches here, we've usually been able to project up, but we're not sure how accurate our ellipse is. So what we do is we take it to our auxiliary view. I'm going to use the center point here of 3. Take the distance to find where our turning point is. Now that distance is the same on both sides. Now what I do is I take, because I used point 3, I'm going to point 3 in my front view, and I mark that off. on either side to get my turning point in this auxiliary view. Once I've found that, I now project my lines down to where it hits. Okay, so there is where my turning point is, and the last visible part of our shape. Okay, so there is the points that we can see from the turning point 1, 2, 3, 4, 5, and the turning point on the side. I'm going to now complete that in my outline shape, because those are all the points that I'm going to see in the front view. So there is the outline of my curve of interpenetration and the visible part. It will be interesting to see if you wanted to take where it hit your ellipse here up to your branch pipe and down, how close would that get to the turning points that you have there. So if you're happy with that method, you can take obviously where it hits the branch pipe up to the edge of the branch pipe in the front view and project those lines down. Now we're going to move on to the hidden detail aspects. So points 0, 6, 11, 7, 10, 8 and 9. We'll be using the same process. So the first points that are on the other side of our turning point is the highest point of the circle, point 0 and 6. So where it hits my main pipe, I'm going to project those lines up to where they hit point 0 and 6. There is point 6, there is point 0, and obviously 12, and there's 6. The next corner is points 11 and 7. So where it hits my main pipe, I'm going to project it to where point 7 is, and where point 11 is. Next point is 8 and 10. So project this up where it hits 8, very close to point 4 there, and very close to where point 10 is. So pretty much you've got the same points there. Okay, and our last point is point 9, which is on the hidden detail where it hits that corner. And there we've got all the points on this side. Those are going to be hidden detail. So I've got most of my points coming around here. Just remember, from point 6 it went up to the turning point. The same on this side. Here's my turning point. So point 0 going up there. Then remember, this is the bottom of my pipe, that is the top of my pipe, so we need to just fill in those little bits in hidden detail. Straight line coming from the branch pipe, tiny little bit of hidden detail there. And that gives us our curve of interpenetration for this shape. Our next step is they want us to develop the branch cylinder and show all construction. So for the development of our branch pipe, what are we going to need? We're going to need the heights. Now remember, the heights we are going to have to get from the front view. That is the true height of our shape. We must get it from these points in our front view. The width we need to get from our top view. Now, because this is a circle, what we're going to do is calculate the circumference. Okay, so let's remember the calculation is 2 pi r, all. So we need to calculate that. There is also a construction method to calculate the circumference of the circle. So I've calculated using the diameter. The diameter of our circle here is 60, so pi times d, 60, gives me a measurement of 188.46. You need to obviously check where you've got a measurement of 180. So you could either take that measurement down, so it won't fit in horizontally anywhere. So either you're going to rotate it and draw it down like this. I'm probably going to fit it in the space down here at the bottom. I've marked off my length of 188 and I've just got my 2 lines at the end there. What I'm going to do on this side is do my construction for my line division method. So take any angle, we need to mark off 12 points on there and then join them up to our vertical line. We've got our divisions and we're now going to project the lines across for each of those points. So there is the development of our branch pipe if it was a totally round object. So now what we're going to do is we're going to find where the specific height measurements are on each of these points. Remember, we need to find those in the front view because that's where we're going to find the true sort of length of the actual branch pipe. So let's start. I'm going to do that numerically, so I'm going to start with point 0 and point 12 here at the top of my shape. Get the distance that I need, go to point 12, mark it off, go to point 0 and mark it off. Next step, we're going to point 1, so point 1, and mark it off. Now remember, in there we've got our turning point, which we'll come back to later. Here's point 11. Go mark off point 11. See why this is quite important, just to measure these. Okay, 2 and 11 I've got at the same point here, sorry, 2 and 10. So get my distance. Go and mark it off. Now point 3. Slightly longer than point 9. There's 3.9. Come down here. 4 and 8 seem to be on the same point as well. Okay, here's point 7, I in detail. Point 5. And our bottom point 6. Okay, there are all our points on our pizza slices. And the last thing we need to do is just find the turning point now. So how do we calculate the turning point? The height we need to get from this measurement. The width we need to get from our top view, and in particular the auxiliary view. So we've projected our point here. So what I'm going to do is I'm going to take my distance from my turning point to point here, 0.6. So this is the longer distance. So 0.6 to 0.5. So if I go to 0.6 and I was going to 0.5, this is the measurement that I needed. So there is my one turning point. Now this distance will be the same on the other side, but this is going from 0 to 0.1. So here is 0 going towards 0.1, mark that off. Project our line. And let's find that turning point. So now we go to the front view to find the turning point. So here is where it's going from 0 to 0.1, and we find the turning point here. So we need to take that distance. We find that corresponding turning point in our development, which was this 0 going to 1, and mark that off. So here is the first turning point, and that's where it is. Our second turning point down at the bottom here. So this is where 5 is going to 0.6. And we're going to get that distance there. And come and mark it off. There's the turning point at between 5 and 6. And there is our edge. We've got all our points now. Let's join them in. Remember, it is a circle here, so these points need to be curved. There is the completed outline of our branch cylinder. Because this is a circle, none of these lines would be in dark lines. We've just got the outline of our shape. And that is the end of the 2016 trial paper.